Okay. Manahil, are you still there?
Yes, ma'am.
Okay. Um, are you able to see the screen?
Yes, ma'am.
Yes. So we're just gonna continue with what we were busy with the other day. But before we continue, I just want us to look at one of the expressions here. Sorry, equation. Let's look at 5. And I just want you to tell me how are we going to compute 5. Just a quick reminder on how to do this. Manahil,
Ma'am, you add the 4 and the 6.
the add.
You add the 4 and the 6 and then you times it by 2.
You add 4 and 6 and you times it by 2. And why are we timesing it by 2?
Because it will give us 20.
Well, you said because it will give us 20. And why do we want to have 20?
It's because this is an equation and they want the answer to be 20.
Okay, so here the first thing that you're going to do, we don't want a 20, but we want to solve for x, right? So the first thing that we're going to do is to add the like terms. The like terms have the same variables, and the variable has the same exponent, right? So in this case, the ones which have the same variables is 4x and 6x. They have variable x, right? And then both the x has exponent 1 or to the power of 1. So that means these 4x and 6x are like terms. So that means we're going to add them together to get a 10x, right? Because there's like that is the friend over there, x. So it's going to be 10x is equal to 20. 10x is equal to 20. So now you're going to ask yourself, how do I get rid of the 10 that is before the x? Because at the end, you want to have a final answer of x is equal to this, x is equal to that, x is equal to whatever, not 10x is equal to whatever. We don't want the value of 10x. We want the value of just 1x, right? Or just x value, right? Or just whatever variable, not 10 variables, 2 variables, 3 variables or whatever. Ne? We just want to end up having x is equal to something, right? So by so doing, the only time you can get rid of something that has um a variable, you want to get rid of the number before the variable, you can only divide by that very same variable. And now, thing is, when you are doing it or when you are dividing for just one term, you will be wrong. Your answer is going to be wrong. So that means we have to make sure that whatever that we do for that term, we have to do for all the terms on the equation or in the equation, right? So we're going to divide the 10x with 10, and we're going to divide this 20 that you see over here with 10, right? I'm just going
Ma'am,
to
can
write.
you re-explain?
We have 4x plus 6x is equal to 20, right? 4x plus 6x is equal to 10x. 10x is equal to 20, right? Now, you want
No.
to know what to do to get rid of this 10 that you see over here, right? The only time you can get rid of it by it. So it's going to be divided by 10. So whatever that you do for one term on an equation, you need to do for the rest of the other terms. So we have another term, which is this one divided by 10, right? And then this 10 is going to be cancelled by this. And then that means we will end up having x is equal to, let's see, this will cancel that. 2 divided by 1 is 2. Then our x is equal to 2, like that. Any question?
No, ma'am.
Okay. Let's have you do this one, number 6. No.
Ma'am, you're going to move the 3 and change it to a -3 because you're going to say 5x minus 5x minus 3x, and that gives you 2x. And then you can write 2x equals 42, but 2x by the 2, and the 40 by the 2, and 40 divided, so x equals 20.
Wow, Manuel, that's great. I'm glad that you remembered that when we transpose, we change the sign, right? When it crosses an equal sign, it changes the sign. If it's negative, it's going to become a positive. If it's positive, it's going to become a negative. All right, that's absolutely good. Now, great. That's good. Um, now let's try to do number 7. Um, what are we gonna do for number 7?
You are going to change x, the negative x to a positive x, and you're going to say x plus 3x x plus 3x, which equals to 4x plus.
You are going to do what? Why are we changing the x to positive x?
Is because we're going to say 3 x plus 3x.
Wait, why are we changing the sign?
It's because we're putting the x to the other side
Which side?
next to the 3x.
So that will only apply if it crosses an equal sign, if it jumps an equal sign, right? So the law
Yes.
is applicable if it crosses or if it jumps the equal sign. So if it was on the side of the equal sign and we are transposing it to this side, or we are taking it to the other side and it crosses an equal sign, then it's going to change the sign. But then if you move it around here, it's 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 not crossing an equal sign, so that means the sign will remain the same. Okay?
Yes, ma'am.
Only when we are crossing the equal sign or jumping to the other side of equal sign. But if it's just on one side, it remains the same. Okay, now let's try to redo it then. Mhm.
Ma'am, can you re-explain?
So the changing of sign, ne?
Yes.
The changing of sign only take place when we are crossing an equal sign. So if we are crossing this x to the other side of the equal sign, the other side of the equal sign, this is the equal sign, right? So if it crosses the sign, if you move it and it has to equal sign, that means the sign is going to change. If it's negative x, that means it's going to be positive x on the side, right? If it's positive 3x, that means when it comes to the other side, it's going to be negative 3x. Okay,
Yes, ma'am.
great. So it will not apply if you are just moving it around. Like for now, we are just moving them closer to each other, and there is no equal sign. If you look properly here, there is no equal sign. Equal sign is over here, and you are taking the x to the side. There is no equal sign in between. But if you are taking it to the other side, then means it's going to be plus x. But because here it's not going to cross an equal sign, that means the sign will remain the same. Okay? And did you get it?
Yes.
Okay, now let's do it. Okay. So we have 3x plus 1 minus x is equal to 0. So it's the same as 3x minus x plus 1 is equal to 0. And then 3x minus x is equal to 2x plus 1 is equal to 0. And then I'm going to take my 1 to the other side. See, when I take it to the other side, it crosses an equal sign. That means it's going to be 2x is equal to, it's in positive. So that means here it's going to be negative 1. And then now I want to get rid of the x, sorry, I want to get rid of the 2 because I want to be left with x. X is equal to whatever. That's the part of answer I want. So to get rid of whatever that's before x, you're going to divide by that very same number, then divide it by this very same number 2. So whatever you do on the left, you do on the right. Or whatever you do for one term, you're going to do for the rest of the time. Same thing. Divided by 2, divided by 2, divided by 2, right? And then this 2
Yes.
is going to come 2, and then we're going to be left with x is equal to negative 1 over 2. And this should be our final answer.
Yes,
Answer.
ma'am.
Mhm. That's good. Did you understand it?
Yes.
Okay. I'm gonna wipe here, and then you answer number 8.
Mm, ma'am, it is this. Okay, so first you're going to say x plus, um, x plus 4x plus 20, and this equals to 5x plus 20, and you're going to take your plus 20 and change it to a negative 20 across the equal sign, and so it's going to be um 5x equals negative 55 minus 20, and negative um negative 55 minus 20, 20 equals positive 35. No, it's negative 35.
Negative 55 minus 20, how much is it?
Negative 35.
How did you get negative 35?
Or positive 35.
How did you get that?
A negative plus a negative equals a positive.
A negative plus,
A negative equals a positive.
no, no, no. A negative plus a negative will give you a negative, right? But then that's not the law. It's not applicable here. So what you need to do is to know that when you have a negative and then you're gonna be subtracting something from a negative, that means you're gonna have a higher negative number, a higher than the one that you are adding. Like you see, you have negative 55 over here. The negative 55 minus 20. Like let me try to find a simpler way to explain to you, right? Let's say for example, your sister your sister borrows you 55 rands, right? Ne? How much do you owe your sister now? If your sister borrows you 55 rands, how much do you owe your sister?
35 rand.
No, no, no. Listen. Um, you go to your sister and you want to buy chocolates, and uh, she gives you 55 rands. How much do you owe your sister?
55 rands.
55 rands. And then the following day, tomorrow, you go to her again and say, I want to buy sweets today. And then she borrows you 20 rands. How much do you owe her?
75 rands.
75 rands. So that means it's going to be minus 75. Okay. So it's negative minus negative. So we are minusing from the minus, right?
Yes.
Yes. And if it was like this, it was negative 55 plus 20. That means you would have paid the 20 rands that you are owing. But because you went to get more, it's going to be minus 75. So it's negative 55 minus 20. And in case you're not sure of the numbers that you're going to be adding, if the sign is going to be plus or minus, you can always use a calculator unless if they've restricted you from using that calculator. But this is how you should think about it, right?
Yes, ma'am.
Right. Do you have okay? 5x is equal to negative 75. Uh-huh.
So then you're going to say that 5x divided by 5 equals x equals um negative 3.
Negative 3.
Oh no, no, sorry, no. Not negative 3. Um wait. Negative 15.
Negative 15. Okay. Another thing that I can advise you, Neb, is to try, as you'll be home at least once in a day or once in 2 days, or try to push yourself as hard as possible to practice. Okay. Because practice is very much important. So if you keep on doing something over and over and over again, you'll end up knowing it by heart. But if you do it today, and then the next time when we meet, you'll be doing it again, and then you leave it, and then next time that we'll be doing it, it'll be after three years or whatever time. Chances of you getting better at it, or chances of you mastering it are very slim, right? So you need to make sure that you do this thing like on a regular basis. Even if you just do the same, right? You do the same one over and over again, you're gonna end up knowing how to do it, and you're gonna end up knowing that when I divide, like, you're gonna end up knowing by heart that when I divide 75 with 5, I'm gonna get a 15. When I divide 40 with 10, I'm gonna get 4, right? So it'll help you with math, just playing, right?
Yes.
Yeah. Let's see. Okay, we have a different one over here. This is solving equations involving powers. Um, do you know those exponent rules? Exponent laws. Solving an exponential equation, asking the question, to what exponent must the base be raised in order to make the equation true?
No, ma'am.
Do you remember? No, no, I was not asking you a question on that. I was just reading that. Do you remember the exponential rules or laws? Do you remember what they say?
Yes.
What do we say?
Where, ma'am?
The exponential law. When we are multiplying the same base, we add the exponents. When we are dividing, we less the exponent. Do you remember those laws? Okay. Um.
Sorry,
So
ma'am. Back.
okay. So they are saying solving an exponential equation is the same as asking the question, to what exponent must the base be raised in order to make the equation true? Copy and complete the following table. We have x, and then we have 2 to the power of x. You know how we're going to get a value that we have to write here?
Mm, no,
How?
ma'am.
If you, okay, let's try to get, and let's see. Nana Hill,
Yes, ma'am.
try to guess, and let's see if you cannot work with that by just looking at that.
Ma'am, we times the 1 by the 2. X.
Um, um, okay. I'm gonna bring back my screen there. Or are you able to see?
Yes.
Okay. Okay, no problem. Are you able to see when I do my settings?
Yes, ma'am.
Okay. Um, okay, let's see. It says over here, copy and complete the following table, right? We have x, we have 2 to the power of x. So up there you have 1, 3, 5, 7. Do you see that?
Yes.
Those are the x values, right? Those are the x values. So that means we're gonna go to the expression 2 to the power of x, and then where we see x, we're going to replace it with 1. Where we see x, we're going to replace it with 3. Where we see x, we're going to replace it with 5. Where we see x, we're going to replace it with 7 in order for us to get the amounts that we're supposed to put down here. Okay, so this is how you always do it. If they give you x value or x values like they've given you, and then they give you an expression here and they say complete or copy and complete or copy and complete, yes, you're going to do that. So you're going to take whatever that's here and then you substitute it here. Okay, take whatever that's here, substitute it here. Take whatever that's here, substitute here in order to get the amount that you're supposed to put here. Take whatever that's here to substitute here to get what you're supposed to have over there. Do you get it?
No.
Okay. No, 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 no. Okay. So for this one, we have 2x. It's 1, which is the same as 2 to the power of 1, which is the same as 2, right? So this is it. Okay. Anything
Yes.
to the power of 1 is equal to that very same number. And then we have 2 to the power of x. X is equal to 3. We're going to say 2 to the power of 3, which is the same as 2 to the power of 3, which is the same as 8. Do you get it? So you can put this on your
Yes.
calculator to get a 3. And then let's see 2 to the power of 5, which is the same as 2 to the power of 5, which is the same as, what is 2 to the power of 5?
25.
2 to the power of 5 is 25. How? 2 times 2 is 4 times 2 is, no, it can't be 25. The number that you're supposed to get has to be a multiple of 2, because you're going to say 2 times 2 times 2 times 2 times 2, right? So it's 2 times 2 is 4,
32.
8 times 32 years. And I can
Yes.
take 32, and then we have this one, which is 2 to the power of 7, the same as 2 to the power of 7, which is the same as, what is this? 32 times 2 is how much? 64. 64 times 2 is at 128.
Yes, ma'am.
Okay, now let's see. Let's see, let's see, let's see. And then we have another one here. They say copy and complete. Copy and complete. Copy and complete. Let's try to complete this one.
Mm,
How is it? Mm-hmm.
mm, ma'am, the foot the the first term is going to be 1.
Why is it 1? How did you get to 1?
So, ma'am,
Mm-hmm.
3 to the 3, no, it's going to be 0.
Why is it 0?
No, ma'am, it's 1. It's because it's the first term equals 1.
First term is equal to 1. So, so you're saying it's going to be 1 there. So 3 to the power of x is equal to 1. Okay. 3 to the power of x is equal to 5. So now we have to solve for x. So, do you have an idea of how we're going to solve for x here?
No, ma'am.
Okay. So when you have it like this, Manahil, you have to make sure that the bases are the same so you can work with exponents, right? You have to make sure that the bases are the same so we can work with exponents, okay? So the first thing that you're going to do is to say, okay, I have 3 to the power of x, which is equal to 1. You're going to ask yourself, can I change this 1 so that I have 3 to the power of something, right? Can I have 3 to the power of something? I don't know what, but can I not change it? Or if I can't change this, can I change this 3 so that it's 1 to the power of s whatever, right? So that you can have the same basis, and then if you have the same basis, you can now work with exponents, right? So I'm just gonna wipe this and rewrite it. So it's 3x is equal to 1. Do you know what is it that we can change 1 to so that it has a base of 3?
Um, add 2. 1
Um,
plus 2 equals 3.
if we add plus 2, this is what we're going to have. Remember, we said what we do on the right must be done on the left. So that means we're gonna have something like this. Do you
Yes,
think this will work?
yes.
Okay, let's see. Now, how do we do it? Wanna see how are we going simply?
So 5 equals, uh,
But these are not like terms, ne?
yes.
So that what does that mean?
We, we cannot simplify.
We cannot add them, yes.
Yes,
Okay. Remember the other time when we were having a lesson, we said anything to the power of 0 is equal to 1.
yes,
So we can have 3 to the power of x is equal to, because we want to have a 3, we have 3 to the power of 0, because 3 to the power of 0 is equal to 1. Or you can check on your calculator there. If 3 to the power of 0 is indeed equal to 1. Right, so that we're going to make sure that we apply that. Remember, we said anything to the power of 0 is equal to 1. And you must make sure that you remember this all the times, right? Okay.
yes,
Good. Now that we have the same basis, we can work with the exponents, right? We can bring the exponents down. So when we bring them down or when we work with exponents, we're just gonna forget about the 3, ne? Then we say we write it exactly as it is. X, oh no, X, there's an equal sign between, is equal to 0, right? And then this is going to be your final answer. So here it's going to be 0. Did you get that?
yes.
Okay. And then how do we do number two?
Um, um, 3x equals 2
Mm-mm. Here we have already been
times
given.
2.
Remember, these are x values.
Oh, ma'am, 3 to the power of 2.
3 to the power of 2. Perfect. So it's 3 to the power of 2. How
And
much?
that equals 9.
Perfect. Perfect. Absolutely perfect. Um, do you maybe want to try um this one? We did it together just now. Um, x 3 to the power of x is equal to 27. I'm just gonna wipe it and then put it next to here so that you can have like a reference, okay? 3 3x is equal to 3x is equal to 27. 27. Okay. Uh yeah, what's gonna be the next step? What did we say we have to start with?
Um, we add, we minus the 3.
What did we do here? Look at
A,
here.
a
What
cubed.
what did we do?
We 27 to the power of 0.
27 to the power of 0 is equal to 1, and 3x to the power of 3 to the power of x is equal to 27 to the power of 0. 27 to 0 is the same as 3x is equal to 1. Is it true? Is it the same as this?
Yes.
Is it?
No,
Is it?
no, ma'am.
No. Why is it not the same?
It's because it's not, um, 3.
Also, this one starts with 3.
Yes, ma'am.
What's the difference between the two? This and this.
It doesn't give the answer.
The difference between this and this.
Yes, ma'am. No, it's not the same.
What is the difference?
The, the difference is it's that it's not 27.
Perfect. So the difference is that the other one is not 27 and on the original one we have 27. So that means we cannot say 27 to the power of 0. So what I said we are supposed to do, Manahil, in this case, when you have exponents that is a letter and you want to know the value of the letter or you want to solve for that letter, in this case we are solving for x, you're gonna have to try and make sure that your bases are the same so you can work with the exponents, right? You're gonna try and have the same basis so that you can work with the exponents, right? So once the bases are the same, then we can easily just forget about them or move everything down so that they no longer there. They cancel out, right? Do you get me? Hence, in this
Yes.
said 3 to the power of 0 because we wanted to make sure that we have the same basis of 3, right? We can either change the 3 to the power of x, this base, or this base, right? We are not restricted to change that just this one. We can also change this one, right? But in this case, we had to change the 3 to the power of 0 because it was the easier one, right? We know that anything to the power of 0 is equal to 1. Hence, we just happily just said 3 to the power of 0. Then the bases are now the same, which is 3 and 3. These are the bases. They are the same. When they are the same, we can work with exponents. Hence, we had x is equal to 0 because the 3 and the 3 are the bases and they are the same. We forgot about them and focused on the exponents. So I want us to do the same thing on here. Do you think we can change the 27 that we have x to the power of something? I mean, 3 to the power of something.
Um. Oh, ma'am, we can change. We can make the 3 to the power of 3.
Perfect. 3 to the power of 3.
Yes.
Perfect. Perfect. So you see now the bases are the same. Now we can work with exponents. So with exponents, that means we're going to be left with x is equal to 3. And this is going to be our final answer. 3 over here. And in case you want to check if it's correct, you can substitute here and say 3 to the power of 3 is equal to 3 to the power of 3. And if it doesn't give you 27, then it's wrong. But if it gives you 27, then it's correct. Ne?
Yes.
Do you get it? Do you think you're understanding it?
Yes.
Okay. Let's do the last one here. They say x is equal to 5. What is going to be 3 to the power of x?
So, um, 3 to the power of 5.
3 to the power of
5.
3 to the power of 5. Mm-hmm.
Which equals to 243.
2, 4, 3. So it's 3 times 3 times 3 times 3 times 3. It's 3, 4, 2, 4, 3. So the answer is
Yes.
going to 4, 243. Okay, do you have any question for me, Manahil? Let me see. Oh, it's
No.
fast. Did you understand everything that we did today?
Yes.
Okay. Just try to make sure that just try to make sure and that you study, né? Like you practice because practicing is very much important, Manahil. It helped me a lot, so I think it'll help you too. Well, I don't think I know it's gonna help you too to do well in maths. Okay. Let's see. Okay, since you don't have any question, let me just check if I do too. Yes. It's not the last one. We have 7 minutes. So let me try to no. Let me try to share you the screen. Uh share the screen with you so that we can look at statements. Let's see. Mm, okay. Uh, uh, Okay. Okay. Let's look at number three. Do you see Karina's method?
No, ma'am.
Are you not able to see the screen?
Yes, I can see, ma'am.
Okay. You almost had heart attack. Okay. So you see Karina's method. Karina solved equation 3 to the power of x as follows. 3 to the power of x, hence 3 to the power of x is equal to 3 to the power of 3, hence x is equal to 3. This is the same thing that we did for the rest of the thing expressions, right? Now we're going to use the very same method to do what? To solve for x in each of the following. So let's start with the first one, right? We have 2 to the power of x is equal to 32. What do you think it's going to happen here? How are we going to work this out? What is the first thing that we should do or first thing that we need to think about? What do
We can we we
Mhm.
can square cube the 32.
Square cube the 32 and how much is that? Square cube. Square cube. What do you mean by that, Manahil?
Square root of 32 equals 4.
4. So that means
I don't know, ma'am.
how did we do this once? Manahil, how did we do this one?
Ma'am, um, we square root the we square root the 32.
What do I write?
32 into a square root.
And that's it.
Yes.
And what is this?
Um, 32.
I mean, why are we having this? What is it? Is it x is equal to this or what? What is it?
X equals 4 square root 2.
X is equal to 4 square root 2.
E- e- yes.
Okay. Um, I think we ran out of time now, but take a screenshot of this and then try to do it. And you can also take a screenshot of what we did in case you want to remind yourself of what we said over here. I'm just gonna wipe this over here and hopefully you'll be able to see properly. Did you take screenshots?
Yes.
Okay, cool. Enjoy the rest of your evening, Manahil, and your week. I'll see you probably in the next lesson. Bye.
Yes. Bye, ma'am.
So